The last video we have discussed what is called a coplanar forces. What is called a coplanar forces? If all the forces lying on the same plane are called a coplanar forces. Suppose some forces acting on the first plane and remaining forces acting on the another plane, then that forces are called non-coplanar forces. Now we are going to discuss what is called a generalized theorem of moments or a principle of moments. And the statement is here: if any number of coplanar forces acting on a rigid body have a resultant, then the algebraic sum of their moment about any point in their plane is equal to the moment of their resultant about the same point. Suppose we take B1, B2, suppose we take B1, B2, B3 up to Bn number of n number of forces, n number of coplanar forces, which may be a parallel forces, concurrent forces, or collinear forces. Anything you can take. For our convenience, I take here all the forces are parallel forces. Suppose B1, B2, B3 up to Bn are parallel forces. Therefore, the force B1 acting at A1 and B2 acting at A2, therefore the resultant R1 acting at Z1, and the B3 acting at A3, therefore the resultant of B1, B2 and B3 can be taken as the resultant of the resultant of R1 and B3, therefore R2 is the resultant, therefore here R2 is the resultant of the two forces R1 and B3. Likewise, Rn is the resultant of the forces Bn and the previous resultant Rn minus 1. And we take B1 be the perpendicular distance, from O to the fixed point O to the first force B1, the perpendicular distance from the force B1 to the perpendicular distance from the fixed point O to the first force B1. Similarly, we take B2 is small b2 is here I take differentiate as the blue color. So small b2 is the perpendicular distance from the fixed point O, to the force B2. Likewise, B3 is the perpendicular distance from the fixed point O to the force B3. In general, Bn is the perpendicular distance from small bn. Here we take red color as a capital Bn, blue color as small bn. So for small bn is the perpendicular distance from the fixed point O to the nth force Bn. Likewise, any number of forces we take. So we how to calculate the n number of forces, the moments of n number of forces. So we take B1, B2 be the any number of coplanar forces and O be any point in their plane. R1 be the resultant of B1 and B2. B1 and R2 be the resultant of R1 and B3. R2 is the resultant of R1 and B3, and R3 is the resultant of R2 and B4, and so on until the final resultant of R is obtained. Now apply the variance theorem to the forces B1 and B2 and R1. Therefore, the moment of B1 about O is equal to the moment of B2 about O is equal to the moment of the R1. What is the R1? R1 is the resultant of B1 and B2. Similarly, we apply the variance theorem to R1, B3 and R2. Here R2 is the resultant of R1 and B3. Therefore, we get that moment of R1 about O is equal to the moment of B3 about O. But what is the moment resultant of R1 and B3? R2. Therefore, by variance theorem, that is equal to the moment of R2 about O. Combining equation number 1 and 2, we get that moment of B1 about O equal to moment of B2 about O plus the moment of B3 about the same point O. Therefore, we get that this is equal to the moment of R2 about O. Proceeding like this till all the forces are exhausted, we get the theorem. So, we get the theorems. Okay. Now, let B1, B2, B3 be. Now we take B1, B2. So here we differentiate as blue color. So for B1, B2, B3 up to B and B, small B1, B2, B3, the perpendicular distances of the distance of the fixed point O to the B1. Therefore, small B1 here, small B1 is the perpendicular distance from O to the first force B1, and the B1's B2 is the perpendicular, small b2 is the perpendicular distance from the fixed point O to the second force B2, likewise. So we get that we apply the above theorem or the variance theorem, we get that B1 into small b1, here small b1 is the perpendicular distance from the fixed point O to the first force B1 plus therefore we get B1 small b1 plus B2 small b2, that is equal to B into capital R. Here capital R is the resultant of all the forces, and O is B small b is the result of the perpendicular distance from the fixed point to the last force. Therefore, we get equation number 1. Now we are going to discuss the corollary of the last theorem, that is the generalized theorem of moments. The first corollary says that the algebraic sum of the moments of any number of coplanar forces, about any point on the line of action of the resultant is 0. That is, if the basic point O about which the moment is taken, which happens to lie on the line of action of the resultant. Suppose O is the fixed point. Suppose any number of forces B1, B2, acting on a coplanar, all the forces are coplanar forces. Therefore, all the forces lie on the same plane. Suppose the resultant passes through the point, the fixed point O. Then the distance between the resultant is equal to 0. Therefore, small b is equal to 0. Therefore, from equation number 1, summation of B1 into small b1 is equal to 0 into capital R. Therefore, we get capital B1 into small b1 is equal to 0. Hence, we get that the algebraic sum of the moments of any number of forces about any point lie on the action of the resultant is 0. Suppose the resultant passes through the fixed point O, then that is equal to the algebraic sum is equal to 0. The next corollary 2 says that if the algebraic sum of the moments of any number of forces about any point in their plane is equal to 0. Suppose the algebraic sum is equal to 0, that is the algebraic sum is equal to 0, then either the resultant passes through the fixed point O about which the moment is taken, or the resultant is 0. What is that? Then either the resultant passes through the point about which the moment is taken, or the resultant is 0. The later case, that is the resultant is 0, is called, when the resultant is 0, then the forces are called the equilibrium forces. What we are assumed that, suppose the algebraic sum of any number of forces about any point is in their plane is equal to 0, that is summation of b1 and small b1 is equal to 0, then from equation number 1, summation of b1 into b1, that is equal to 0. that is equal to 0, the algebraic sum is equal to 0, then from equation number 1 small b into capital B equal to 0, that means small b equal to 0 or r equal to 0. Suppose small b equal to 0, what it means that the basic point O about which the moment is taken, the basic point O about which the moment is taken, and which lies on the line of action of the resultant, and which is the line of action of this resultant. If r equal to 0, that is the resultant r equal to 0, it means that no resultant for the system, that is the forces are in the equilibrium, that is when r equal to 0, the forces are in equilibrium, or the forces are in equilibrium. The third corollary says that if a system of coplanar forces is in equilibrium, suppose a system of coplanar forces is in equilibrium, then the algebraic sum of their moments of any point in their plane is equal to 0. The last corollary says that if the forces are in equilibrium, suppose any number of forces acting on the point, acting on the plane, suppose O is the fixed point, suppose the resultant passes through O, then the system of forces are in equilibrium. So if what we assumed in corollary 3, if a system of coplanar forces in equilibrium, then r equal to 0, that is the forces are in equilibrium. Therefore from equation number 1, summation b1 into small b1 equal to b into capital 0, that is equal to 0. But this is nothing but the algebraic sum of their moments of any point in their plane is equal to 0. Therefore we get the corollary 3. So okay, thank you.